Alright, we are doing section 4.7, graphing linear functions. This is the last section in chapter 4. So function notation is f of x equals mx plus b. Now, the only difference between an equation and function notation is it has f of x in the same place that we usually have a y, but we use it the exact same way, we graph the exact same way, it's just new notation. So what is the value of the function f of x equals 3x minus 15 when x is negative 3? So what you're going to do is put in a negative 3 for x and simplify. Simplifies to negative 24. That's it. So we've done this kind of thing before. The only thing that's new is the notation. Find an x value. So before we were finding the function value, now we need to solve for x when the function is 6. So this time 6 goes in the spot of f of x, and we need to solve it for x. So we're going to add 10 to both sides. We have 16 equals 2x. Divide both sides by 2. And x is 8 when the function is 6. Okay, domain and range. We know what these are. We've used them several times. The domain is all the x values. We knew that. Where the function is defined. Okay, so the domain is all the x values, and the range is all the y values. What we're going to say this time is that the range is all values of f of x. Remember, f of x is the same thing as y, where x is defined. In the domain. So new definition, not really a new meaning. It means the same thing that we've been using for range all along. Okay, graph a function. We have a gray wolf population in central Idaho. It was monitored over several years. The number of wolves can be modeled by the function f of x equals 37x plus 7, where x is the number of years since 95. Graph the function and identify its domain and range. Okay, so we need to, the easiest way to graph any function is to do the xy chart. In this sense, we're doing f of x chart. So if x is the number of years since 1995, we have to start with 0. Whenever it's time, we always start with 0. We never start with a negative number. So if we were to put 0 into x, we would get 7 for f of x. If we put 1 in, we would get 44. And if we put 2 in, we would get 81. So now we need to graph it. Okay, this is x. This is y, or f of x. Go by ones. And let's go by 20s up the side. Okay, so for 0, we have 0, 7, which is approximately right there. 1 goes with 44, and 2 goes with 81. Okay, connect our 3 dots and keep going. But we don't have an arrow to the left because we can't have negative x values. We can't have negative time. So now when we need to figure out what the domain and range is, the domain, we're looking horizontally, which values work horizontally. Well, we don't start with negative, so we know we're going to start with 0, and it's everything bigger than 0. So x is greater than or equal to 0. And our range, those are the function values that work for our values of x. So what that means is we're not going to pick range values when we don't have x values there. So we're looking at the same thing. We're looking at the green line, and we're looking at what are the y values that go with that green line. The lowest value we have is 7, and it goes up from there. So our f of x is greater than or equal to 7. Okay, we have a parent linear function. The parent linear function is f of x equals x. So the slope is 1, the x-intercept is 0. So that's going to look like this. something like that. So graph these functions and compare them with the graph of f of x equals x. So I'm going to go ahead and graph both of the parent functions on this in red. Okay, and now we're going to graph the other ones and compare. So x plus 3, that starts at 3. Y-intercept is 3, but our slope is 1, so it's still going to go same direction. So compare this with the graph of f of x equals x. Well, g has moved up 3, really. Okay, for b, our g is 2x. Still has 0 for the x-intercept. This time our slope is 2. So what's the difference between the green and the red? It still has 0 for the x-intercept. It looks like it's steeper. I guess that's h of x, not g of x. I'm going to say that's twice as steep. That's a good way to describe it. Okay, we have one more question. We have a cable company charges new customers $40 for installation and $60 per month for its services. The cost to the customers is given by the function f of x equals 60x plus 40, where x is the number of months of service. To attract new customers, the cable company reduces the installation fee to $5. A function for the cost with the reduced installation is given by f of x, g of x equals 60x plus 5. Graph both. How are they different? Okay. So we probably want to go by ones on the x-axis. And we'll probably go by 50s up along the y-axis. This is f of x or y. Okay, so our f of x function is, we'll do in blue, it's 60x plus 40. So we start at 40, and then we go up 60 over 1. This is f. And g, I have red, starts at 5 for our y-intercept this time, goes up 60 over 1. This is g. How is the graph of g related to the graph of f? If I did a good job graphing this, which I kind of did, they should be parallel. And it looks like g is 35 lower than f. 35. Okay, and that was the last question in chapter 4.